Have you ever gazed upon the night sky and wondered how a star is born? This question, although simple, unravels a cosmic tale of astronomical proportions. Stars, those twinkling marvels that adorn our night sky, are colossal celestial entities. Composed of searing hot gases, they emit both light and heat. Yet, their origin story is far from ordinary. It's a journey marked by unimaginable forces, vast expanses of time and cosmic dust. The birth of a star, as you'll soon discover, is a fascinating cosmic event. The birth of a star begins in a place we call a stellar nursery. Now imagine a vast, cold region of space where gas and dust float freely like particles of fine sand tossed into the wind. These particles are the raw materials for star creation, and it is within these stellar nurseries that they begin their cosmic dance. As we delve deeper into the stellar nursery, we find an almost ethereal realm where the laws of physics weave intricate patterns. The gas and dust in this environment are not simply drifting aimlessly, they are subject to the ever-present force of gravity. As gravity asserts its influence, these particles start to clump together, creating denser and denser regions. This process, while seemingly simple, is the first step in the creation of a star. These clumps of matter, pulled together by gravity, begin to form what we call a protostar. A protostar is essentially an embryonic star, the seed from which a full-fledged star will eventually grow. In this stage, the protostar is still relatively cool and lacks the intense heat and pressure at its core necessary for nuclear fusion, the process that powers a star. But as more and more matter accumulates, the protostar continues to grow denser and hotter, setting the stage for the next phase of stellar evolution. So, the protostar, the embryonic star, takes shape. It's a fascinating process, isn't it? This is the story of how the twinkling stars we see in our night sky begin their stellar journey. Now the protostar is not yet a star. It is in its adolescence, maturing and growing. Imagine a teenager full of potential, yet still accumulating the wisdom and experiences needed to truly shine. This is our protostar, a celestial adolescent in the heart of a stellar nursery. Like a youngling, the protostar is on a journey of growth, continuously gathering mass from the surrounding cosmic dust and gas. As it swells, it's like a pot of water reaching the boiling point. The pressure at its core skyrockets and the temperature soars into the millions of degrees. This intense heat and pressure set the stage for a truly spectacular event, nuclear fusion. You see, nuclear fusion is no ordinary process. It's the ultimate power generator, the cosmic engine that fuels a star. At these soaring core temperatures, hydrogen atoms, the most abundant element in the universe, are squeezed together so tightly they merge to form helium. This fusion process releases an incredible amount of energy in the form of light and heat, which we perceive as the glowing twinkle of a distant star. And just like that, with the flick of nature's almighty switch, our protostar takes a giant leap towards adulthood. The cosmic dust settles and a new light begins to shine in the stellar nursery. With the beginning of nuclear fusion, a star is born. Birth, in stellar terms, is a fiery, vibrant event. As the protostar matures, it continues to collect more and more material, increasing its mass. This in turn ramps up the gravitational pressure at its core. A tipping point is eventually reached where the pressure is so immense that the protostar can no longer resist its own gravity. Here's where the magic happens. The core collapses under its own weight, and this collapse triggers a sudden increase in temperature and pressure. This is like the spark that ignites the fuel in a car engine, setting off a chain reaction. This chain reaction is known as nuclear fusion. The intense temperature and pressure at the core force hydrogen atoms to come together, forming helium. This process releases a tremendous amount of energy, causing the star to shine brightly. The energy generated from nuclear fusion creates an outward pressure that counteracts the inward pull of gravity. This delicate balance, known as hydrostatic equilibrium, is what prevents the star from collapsing further. The star will continue to shine and remain stable for as long as there's enough hydrogen fuel in its core to sustain nuclear fusion. This is the moment we've been waiting for, the birth of a star. It's a spectacular event, a testament to the power and beauty of the universe. It's the start of a journey that can last billions of years, shaping the cosmos and providing the building blocks for life as we know it. And thus, from a humble cloud of dust and gas, a radiant star emerges. So, how is a star born? Let's recap. The saga of a star's birth is a cosmic tale of transformation that begins in the vast celestial nurseries of the universe. These stellar nurseries are colossal clouds of gas and dust where elements come together under the force of gravity. Over millions of years, these particles bind, coalesce, and contract into a dense core. This process, like the slow stirring of a cosmic cauldron, brews the initial conditions needed for a star to form. This dense core, now a protostar, continues to contract under its own weight, heating up and glowing brightly. At this stage, the protostar is like a teenager in the throes of growth, not yet a fully fledged star, but no longer just a clump of dust and gas. It's a precarious phase, a race against time and gravity. The protostar must gather enough material to trigger the process of nuclear fusion before its own gravity can cause it to collapse. And then the magic happens. The core of the protostar becomes so hot and so dense that hydrogen atoms begin to fuse together, forming helium. This nuclear fusion releases a tremendous amount of energy, generating light and heat, the hallmarks of a star. This is the birth of a star, a celestial event that brings light to the dark corners of the universe. The process doesn't stop here. Stars continue to evolve and change throughout their lifetime, burning their nuclear fuel and undergoing various stages of stellar evolution. Some stars will live for billions of years, while others will burn out in a few million years. Regardless of their lifespan, each star contributes to the beauty and complexity of the cosmos, each one a testament to the power and majesty of the universe. And that, dear viewers, is the remarkable journey of a star's birth. Each twinkle you see in the night sky has undergone this cosmic odyssey.